Hi Year 12, today I'm going to show you a practical that is going to be used to work out the enthalpy change of a reaction. So, safety specs on. Now I've already pre-measured out 50 centimetres cubed of distilled water using a measuring cylinder. You might want to think about how using a measuring cylinder might have made this practical less accurate and how much of a percentage error that could cause, given that the measuring cylinder increments go up by 1 each time, and I could only possibly see about halfway in between two of those graduation marks. So hydrated copper sulfate is blue, that's the one you're normally used to seeing, and anhydrous copper sulfate is white. Okay, it's not actually iron oxide, that's just what it used to be used for. As I've said, I've already pre-measured out my 50 centimetres cubed of water, and I've got my polystyrene beaker and my glass beaker to try and maximise insulation. In a minute I'm going to, well actually I could do that now. I'm using my Pasco thermometer, which measures the temperature to 1 decimal place. So if I start this, you can see that at the moment the temperature is 14.4 degrees C. 14.3, obviously this water is pretty cold. I suppose the heating hasn't really been on in school. Okay, I'll leave that there for a moment so we can get a baseline temperature. Just remember that in the past, when I've done the demos before, we used a different method where we measured the baseline temperature every 30 seconds for 2.5 minutes. We then missed out the 3rd minute, added our reactant, and then measured the temperature every 30 seconds until it started either returning to its normal temperature or start temperature, or until it sort of started going in the other direction. So it has kind of stabilised now at 14.2. So start temperature is 14.2 for our first experiment. And now I'm going to, although our technician has weighed out 4 grams for us, it might be that we don't actually get all of that 4 grams in into the polystyrene beaker when I pour it in. So I'm going to start by measuring the mass of it in the pot, and then I'll weigh the pot again afterwards, and then we can subtract to find the exact mass that has been added. So I've already tared my balance. So mass with pot is 8.11. Okay, and then mass of pot alone, and then I can do mass of the copper sulfate. Okay, so going to add my anhydrous copper sulfate. Oh, the temperature's gone up to 14.3. Oh, it's gone back down to 14.2. It's flickering between 14.2 and 14.3. So maybe we'll go with 14.25. Okay. Give it a little stir. And you can see that the temperature is rising quite quickly. We want to measure the maximum temperature that it reaches. So give it another stir to try and ensure that it completely dissolves. So, I don't know if I'll be able to show you this. So it has now turned blue, which is the colour that you would expect to see with the hydrated copper. Okay, temperature has reached 19.6, hasn't changed for a bit. Obviously, you need to be careful that I don't spear the bottom of the polystyrene cup. I'll leave that for a moment to see if it rises any further. In the meantime, I'll reweigh my empty pot. So I've tared it. The empty pot is 4.13. So we can see that if we take away 4.13 from 8.11, then that would tell us, oh no, it's gone down to 14.12 now. So it's very, very close, but it is in actual fact 3.99 grams. And when we're doing these calculations, it's really important that we minimise the error as much as possible. The temperature has stabilised at 19.6. So we can see that our temperature change has gone up by 5.4 degrees C. Okay, so our delta T, I'm not sure you can see, oh you can see it a little bit. Our delta T is 5.4 degrees C. So now we're going to start again with that set of practicals. I was just wondering if my lovely assistant might wash the thermometer for me. Thank you, Mr. Leek. Okay, so again, I'm going to do exactly the same procedure. I've already measured out my 50 centimetres cubed of distilled water. I'm going to measure the mass of my blue hydrated copper sulfate in the pot. I'll write my values here. 10.12, so that's pot and hydrated copper sulfate. I've just shortened that because I've run out of space. And then pot alone, and then mass of CSO4. Just in case you were wondering, thank you very much, Mr. Leek, the formula for hydrated copper sulfate is showing that for the copper sulfate, for every 1 mole of copper sulfate, there are 5 moles of water. You will come across what this is all to do with in year 13, so I'll leave you in suspense there. Okay, so I'm going to, again, measure my baseline of my distilled water. And we can see again that the temperature is about 14.2 degrees. I'll leave it for another moment to see if it is going to change anymore. I expect not. Okay, so that's 14.2. Okay, and then end temp over here. I'm going to squeeze it all onto the board. Okay, so again I'm going to add my blue hydrated copper sulfate, and then I will measure the mass of the empty pot so I can work out the exact mass of copper sulfate added. Okay, so we can actually see in this case that the temperature is decreasing. So we're going to measure the temperature when it reaches its lowest point. So 13.4 at the moment, 13.3, 13.2 now, down to 13.1. Now you'll have noticed in both of these instances I haven't used a lid, and obviously if we used a lid then that might make some small difference, but not a huge difference at the moment. Okay, so we've gone down to 13. I'll leave it and see if it's going to reduce any more, and in the meantime I will re-weigh my empty pot. What did I use? Which is 4.09. So here we can see that the mass of copper sulfate is in fact 6.03. Okay, it's approximately 6, but we wanted to know the exact mass. So here we had 3.99 grams of copper sulfate, anhydrous copper sulfate, and the hydrated we had 6.03. And our temperature is still at 13, so we can have 13 as our end temperature, 13.0 to make it 3 significant figures. So we can see that our temperature change here is minus 1.2. So those are the figures that we are going to use in our calculation that I will go through with you live shortly. Okay, have a good day.